In this video, we're going to be going over comparing graphs of absolute values to their parent function and what kind of transformations and translations we might see there. So here we see a table, and this table is pretty awesome. This table goes through what the different types of transformations are, what they look like, and what they mean. This would be a good table to keep handy for quizzes and tests and just general reference as we go through the year. So make sure you take a look at that. It talks about horizontal translations. It talks about vertical translations and what it looks like when it moves up or down. It talks about reflections across the x and the y axis and where that negative sign is, either on the inside or the outside. It talks about horizontal stretches and shrinks and how we're on the inside when you have a stretch or a shrink, and our stretch is going to be when our graph is going to get narrower, and a shrink is going to be when our graph gets wider because it's a little bit backwards because it's on the inside, just like everything else is backwards. Like if we take a look up here, right has a minus sign and left has a plus sign. And so our horizontal stretch and shrink, if we're getting wider by 1/3, which is the reciprocal of 3, and narrower by 2, which is the reciprocal of 1/2. It also is going to go through vertical stretches and shrinks. And on a vertical stretch by 4, that's when our graph's going to get wider by 4. And our shrinks are going to get narrower by that 1/5. And that's going to stay true because it's on the outside. So these are going to be important things to remember and to refer back to be able to help you out. Now it's important to note that the vertex of the graph of G is at the points h, k. Now notice that our h value directs the left and the right movement, right? So that's our h. And our k directs the up and the down. So we have our h value and our k value. Now any absolute value function can be written in vertex form, and its graph is going to be symmetric to the line x equals h. And so that's just important to know. And so now we're going to do some examples. So we're going to be graphing some functions, and then we're going to compare the graphs to the graph of f of x equals the absolute value of x, which is the parent function. And then we're going to describe the domain and the range. So that's new. So in our first example, we have t of x equals 1/2 times the absolute value of x. And so what we're going to do is we're going to use our graphing calculator to help us out so that we can get our values just a little bit quicker. So we're going to go to our y equals. So y equals, and we're going to put in our 1/2. So we're going to type in parentheses 1 divided by 2 close parentheses. And then the absolute value symbol can be found by clicking on the math button, arrowing over to the word number, and that ABS, that's it. So we're going to enter, and then we're going to put our x. Now we also want to make sure that we're graphing our parent function, which is the absolute value of x. So what we're going to go ahead and do is we're going to look at the table of values. So the table we're interested in is our blue table. So we're at second table. And again, we want the blue numbers because the red numbers are our parent function. And we're going to scroll down until we get to -4. There it is. I'm going to write those values in. So here we're going to have value of 2. And then down to -2 gives us a value of 1. And scrolling down to a value of 0 gives us a 0. And scrolling down to the 2 gives us a value of 1. And scrolling to the value of 4 gives us the value of 2. And so now we can go ahead and we can graph that. So we're going to graph our parent function first, which remember is 0 and then 1. So it's just like that V. Right? We're making that V. So here's our parent function. And we're going to go ahead and we're going to graph our t of x. So at -4, we're at a 2. And then we're at a 1 and 0 and then 1 and then 2. And notice here that our graph has gone which direction? How's it grown? Or rather, how has it moved? And what we see that's happened is it has gotten wider, and because then 1/2 is on the outside, it's going to be wider by 1/2. And now we just need to find our domain and our range. So the domain are all of the things that x is allowed to be. So if we look this direction, it doesn't stop growing. Look that direction, we see that it doesn't stop growing. So that tells us that our domain is going to be that x can be all real numbers. For our range, we're going to take a look and go, okay, now on the y's. Is there any stop here? Nope, it keeps growing up. But we see that there's nothing down here in our negatives. And so that tells us that our range is going to be that y has to be greater than or equal to 0. So let's go ahead and let's do another one. So we're going to go back to our graphing calculator. And this time we're just going to go ahead and put in just the function that we need for our table of values. So we're going to have negative. Make sure you don't click a minus sign because it's not the same. And then we'll put in that absolute value symbol of x. And we'll go to our table. Oops, that's the graph. Sorry, we'll go to our table. And we'll get our values. So we're going to go ahead and we're going to take our values and write them in the table. So go ahead and push pause and write those values in the table. And then when you're done, push play. And then let's graph it. All right, so now we've got our values. So we're going to go ahead and we're going to graph our parent function. All right, which is our f of x, our parent function. And then we're going to go ahead and we're going to graph our u of x. So we're going to go ahead and do our values here. I'm going to draw our lines. Here we have our t of x, or rather our u of x, because we're on the second one now. All right, so what's important to know is how it looks. So here we see a reflection. Did it reflect across the x-axis or the y-axis? That's right, it reflected across the x-axis because it went down. So that's how we know it's the x-axis. Now, when we find our domain and our range, we are only looking for the domain and the range of our u of x. So here when we look at what can x be, we see that it keeps growing and it keeps growing. So that tells us that x can be any number it wants to be. So all real numbers. That's what that double barred R means, all real numbers. But our range, take a look at this. There's no blue up here, right? All of the blue lies below our x-axis. So that tells us that our y has to be less than or equal to 0. Let's go ahead and let's graph number 3. So we're going to go ahead and grab our graphing calculator and we're going to plug in our value. So we're going to have the absolute value of x minus 3, and we're going to pull up our table. And we're going to go ahead and put our values in. So go ahead and push pause and get your values and plug them into your table. And then when you're ready to graph, go ahead and hit play and we'll graph them together. And so here we have our table of values. So we'll go ahead and we'll graph our parent function. So we've graphed our parent function f of x. Now we're going to go ahead and graph our p of x. So we're going to go ahead and graph that. And when we graph that, for our p of x, we see that this has moved down 3 units from our parent function. So what does that tell us for the domain and the range? Again, we're just looking for the domain and the range of our p of x. So here we see that x still isn't stopping. It can kind of go and be whatever it wants to be, and we can find a value for it. So our x is going to be all real numbers. And this time we have values going from -3 all the way up, but nothing below that. So that tells us our range has to be greater than or equal to -3. Because that's the line, or that's the spot right there where nothing passes. Let's go ahead, let's do number 4 together. So we'll go to our y equals and we'll plug in our equation. So our absolute value of x plus 2, and we'll look at our table. So go ahead and push pause and get those values and plug them in, and then push play when you're ready to graph it. So now that we've got our table of values filled out, we can graph our parent function, which is our f of x, and we're ready to graph our r of x. And so we can go ahead and graph that, and it looks like it's the same size as far as how wide it is, but it looks like it shifted to the left 2 spots. And now we'll find our domain and our range, again only for our r of x. So we see that x keeps growing and it still has number values, and the same as in the negative direction. And so that tells us that our domain is going to be all real numbers, which is pretty much always the case for absolute value functions. As far as the range goes, notice that we don't have any negative values, none of them. Everything occurs from 0 or higher, which tells us that y has to be greater than or equal to the smallest value of y, which is 0. And so that is how you can use your graphing calculator to help you pull up a table of values. And also, that's how you can find your domain and your range using your graph.